Welcome back to the second part of this video. So if we hit play and then let's go full screen again. When I hit let's actually go back, try this again. So when we actually go to play and hit D, you see all the traces that are around the ship at this time. Those are the traces on those different axes, so they're front, left, and up axis. Those are the traces. The four loops, that's what's creating these traces right now. So the reason we do that is so that we create some variety and the avoidance, because we don't know where it's going to be. We just know it's going to be in front, and so we can avoid something that's in front of us. And so we got the traces down. And now one thing we want to do so that we have some extra security in avoiding is we can do an object avoidance as well. So this object avoidance line is going down here, shoots all the way over here. And then we got scan for object once per tick. And so this is object avoidance tracer. And so we're going to start from the at this location, and then we're going to multiply the trace distance by 4, and then we're going to multiply that by the forward vector and add that to the location and make that the end trace. And so that's going to be real far directly in front of our actor. And so that way we preemptively know that we should avoid an object because we're going real fast. Collision avoidance works great for when you're up close, but this needs to be done preemptively to just avoid ever getting close enough to get stuck. And so this is a great measure to add. And so once it's true, it goes into this trace. And so what happens is it hits the object, and then one trace is sent up, one trace is sent to the left, one trace is sent to the right, and one trace is sent down. And so let's go through this. We first want to get the break hit result from this first hit from that object, because this is going to tell us everything we need to know and to dictate how we're going to avoid this object. So the first thing we want to do is that we want to first trait the line trace. So we're going to replicate a little of what we did before. So we're going to get the forward vector, and then we're going to add that to the direction vector, and add that to the hit where that landed. And so what's going to happen is we're going to get a trace from our location, or where it started, into the impact, and it's going to be offset by this direction vector going to the left, to the right, and up and down. And so this trace goes through, it's true, so that means an object is still there. So imagine we're going to the left, and so it's still an object there. So that means you gotta do another trace. In order to do another trace, we gotta increment forward in the direction that we're on, so that we can continue to scan out until we find the end of that object. And so say, we're doing forward, and then we're going to the left, we're adding this, which is option 4, and we're going to add that to the direction vector. We're going to keep adding it to the direction vector until we find the end of that object. And that will be the false statement. So false happens, and then we're in here. And so now we calculate the distance to avoid that object. And that basically is the vector length that this direction vector is. So the distance to avoid is basically the direction vector. So the vector length of that. And then the distance to the goal is the direction vector plus where the hit location is, which would give us a point within the world, and then we subtract that from the target location, which is our goal, and we get the distance for that, and that's the distance to the goal, and we add that to the stack. And so these are added in order, of course, and then we zero out the direction vector, and then we increment the switch direction up. And so then that's when this happens. It's like, okay, still within loop. Let's say, it finishes finally. Now it goes here to the avoid vector, and then finally calculates everything, and it adds this to the avoid vector. And so right here it starts off by getting the distance from the impact to the actor, and so we want to know how close the impact is. So we get that vector length, and then we map the range for how extreme the avoidance need to be. So if it's real close, then we want to put 5 into the input vectors to make it avoid the obstacle immediately, because it's gonna hit. But if not, we put 1 because it's not that urgent. And so 2 things can dictate which direction it goes in. So we have the distance to avoid, and we have distance to goal. And so this is randomly selected, and then that is outputted, and then we get the minimum float. So we want the minimum distance to avoid, or we want the minimum distance to goal, because those are both good objectives. And then this returns the axis that we want. So 0, 1, 2, 3, 4 is the axis that we have scanning for. And then once we get that, multiply that by the intensity that we get for the impact, and now we have our direction vector to avoid our object, and we add that to the avoid vector, and then this is added. So then now that's all done and calculated, and there you go. So to show you what's happening, let's go back in game. Let's hit play. He just did it right there. Okay, so you can fly right here, and then you can see he even though it's a real short scan, he hit this object and he scanned down. Obviously that was not the choice. He scanned right, not the choice. Scan up. There's no scan there. Scanned left, no scan there. So it's obviously he went left or right and just avoided this object. So let's see if we can get one again. Oh, there we go. Okay. So you can see what happened. He hit this object right here. There's a scan to the, of course, the bottom left, bottom right, top left, top right. No, I mean top. And you see. So he likely chose the bottom. And so he just dove to the bottom right, bottom left. And so that's how that object avoidance works. It hits an object, and then it scans out, and then it has 2 variables that it dictates on. And so what happened there is likely that the bottom was closer to the goal, and that's the one it landed on, so it chose that one. And it landed on distance to goal, and so the bottom left had to be the closest to the goal, and so that's why I chose that one. And so that's why you say it weaved left. And so that creates that more randomness in the AI, and prevents it from getting stuck as often. And so then the last thing that happens, that locks, because that's a do once. It hits here, that's a do once. After this loop's finished, after they all finish, because this is the first one, so this one has to finish and the rest are done. And now we're going to reset the locks and avoidance systems. So it goes in here, goes down here, and then resets the lock. So it unlocks them and then resets this so it can scan again. And so the last and final thing that happens is the updating of these text actors on the ship. Those are right there. Again, speed, pitch, yaw, whirl. So these are just being updated, and you've seen that. So let's go back in game, and you see thrusts in, yaw, pitch, and roll. You see the sparks. So yeah, this is what's going on. Now, as I said before, this is some basic AI. So of course this project can be improved upon. This is just something I want to give to you guys to play with and possibly introduce into your own projects. And next I'm going to be working on the racing AI, because I've already have car AI and I already made some other adjustments to the car AI that I haven't released. It makes it totally different, but then also it's the reason I'm making racing AI, because it's gonna be racing AI. It's gonna be slightly different in the way that it makes turns and etc. And so, just a different thinking project and a way of driving, obviously. And so, next thing I want to make too is I'll be putting some things in the marketplace. So of course I'll be making some AI and putting that in the marketplace. So if you guys have any suggestions, I'm all for it. I just want to say thanks to all the new followers. New stuff is in the works. And of course, I want to make a lot of stuff free. Make sure to stay tuned for what's coming up next, guys. Alright, peace.